domain and range. We've talked about domain and range in terms of quadratic functions, but now we'll be applying that knowledge to different functions, including the functions that we learned about yesterday. So remember that domain is all the values of the independent variable, and the range is all the values of the dependent variable. So your independent variable is usually your x variable, your dependent variable is your y variable. Might not always be x and y, but usually it is. Now, just some things to remember. Anytime that your graph is connected, so if you have like a line or your curve, you're always going to start with x being an element of the real numbers and y being an element of the real numbers as well. And that's because you don't just have specific points. You don't jump from x equals 2 right to x equals 3 with nothing in the middle. If it's connected, you have all the little points in between. You can make an infinite amount of points in between. So we say that both are elements of the real numbers. Now, if you have a line or a curve that ends or begins with an open circle, that means that that point is not included. So for example, if this is x equals -2 right here, that means x equals -2 is not included on the graph or in the function, but everything greater than it is included. So we'll be seeing that today. Alright, so we'll be stating the domain and range for this function right here. So there is no equation for this function, I just kind of drew it. So first thing, this graph is connected here and here. So there's actually two different pieces. This is called a piecewise function. But because we have lines, I can say that x is an element of the real numbers for the domain and y is an element of the real numbers for the range as well. Now the question is though, is it actually all numbers for the domain of x? And the answer is no. We don't have any x values on this side of the function. We do have x values on this side, however, because this part of the function does keep going and going and going and going and going forever. So it will keep going on that way, but not this way. So if I take a look at this, the smallest x value that I have is -4. And then we do have all the x values greater than that because we have, I can travel to the right here, we have all those x values. Now there is an open circle here where x equals +2. But down here we have a closed circle for this piece of the function, so that means x equals 2 is included in the function. So for the domain, x will be greater than or equal to -4. We have all the x values from -4 and greater. Now for the range, will be a little bit tricky because we have two different pieces here and there is a gap. Now first thing, the range just for this section right here, y is always going to be equal to -5. So we can start with that. So y equals -5. It never goes up or down, so we won't have any other y values. Now for this piece right here, if you take a look, the smallest y value is -3. And the function has all the y values greater than that until you get to this point right here. Now remember, open circle means that y equals 5 is not included. So we have to be careful when we state our range. Now first, I know that y is going to be greater than or equal to -3. So -3 is included, that's why it's equal to. And also y is greater than that, we have that included. So remember, for your less than and greater than signs, pretend it's an alligator mouth and y is greater, so the alligator is eating the bigger snack. Now this piece of the function goes up and up and up all the way to 5, but because 5 is not included, I'm not going to have the equal to sign underneath of that. So this means that y is less than 5, but not equal to it. So for this function here, we just have a collection of points. So I'm not going to start with saying that x and y are elements of the real numbers. And that's because, for example, right here we have x equals -10. That would be part of the domain. We don't have any of the values in between until we get to the next part of the domain, which is x equals -4. So for the domain range, all we're doing now is listing what values we are using. So for the domain, and try to have this going from least to greatest, x equals -10, x equals -4, x equals -2, x equals +2, and x equals 5. So I have those numbers there for the domain separated by commas. Now for the range, again, I'm going to look at the y values, but because I want to go from smallest to largest, I'm going to start at the bottom here. So this is y equals -5. Let me show that. And then y equals -3, y equals 0, y equals 6, and y equals 10. So I have those values there as well, separated by commas. Okay, so that's domain and range if we just have a collection of points. We do not say that x and y are an element of the real numbers. We just list the values that we have.